Welcome back to Mr. Hassan's Maths channel. This is question number 6 from the October-November 2022 IGCSE Cambridge Paper 2 Variant 2 from the 0580 syllabus. This question is about sequences and number patterns. Part A is told us about these first 5 terms of a sequence, and they ask us to find the next 2 terms. So they're not asking us in this question to find the nth term in part A. They're asking us just to continue the sequence for 2 more terms. So when you have a question like this, what you need to do is to establish how the numbers are changing. And if you look at the numbers, if you subtract the number from the one before it, so like you do 26 minus 27, you get negative -1. And then you do 23 minus 26, well, that's -3, so it's going down by 3. Right? 18 minus 23, it's going down by 5. 11 minus 18, it's going down by 7. So every time it's going down by 2 more than it did before. So then that means the next one is going to be going down by 9, and 11 minus 9 is 2. And the next one's going to be going down by 11, and 2 minus 11 is -9. Okay, so we can see the next 2 terms as 2 and -9. They did not ask us for the nth term. At the end, I'm going to show you how we would find the nth term if we were asked to, okay, after I finish part B. All right. Now, part B says the table shows information about 2 different sequences. We've got the first 5 terms of sequence A and B. We want to find the nth term for both of these, so we got to complete this table. Okay, so now if we look at the first sequence, to get from one term to the other, we do the same thing. 10 minus 3 is 7. 17 minus 10 is also 7. 24 minus 17 is also 7. 31 minus 24 is also 7. So the first row of differences is plus 7. Every time you have to add 7. Okay, now, so this is a sequence that goes up in 7s every time. Now, that's very much like the 7 times table. The 7 times table is a times table which goes up, makes numbers go up by 7 each time. So this sequence, therefore, is related to the 7 times table. So I'm going to say it's 7n, because it's going up by 7. All right, don't make the mistake of saying, oh, it's n plus 7. No, this is going up by 1. It's a number that's multiplying the n is how the sequence jumps. So it's jumping by 7s. However, if I leave it like this, my first number will be 7. If I put n equals 1, I'm going to get 7. N equals 2 is going to be 14. Here, the first term has to be a 3. So how do I make this become a 3 after I have, 7 times 1 is 7? Well, I have to take away 4. 7n minus 4 will give you 3 for the first term. And if I put 2 here, 14 minus 4, it's going to give me 10. 21 minus 4, 17. If n equals 4, that's 28 minus 4, which is 24. 5, 35 minus 4, 31. So all of these numbers are basically 4 less than the multiples of 7. Right, they're going up in 7s. All right, they're separated by 7s, but each of these is 4 less than the multiple of 7. Okay, so that's what we can deduce from that. So that's the nth term for this first sequence, sequence A. Now, sequence B, again, let's do the same thing. 11 minus 2 is 9. And then 26 minus 11, well, that's 15. It's going up by 9 and then by 15. 47 minus 26, well, that's going up by 21. And 74 minus 47, well, that's going up by, let's just make sure, 74 minus 47. That's going up by 27. So we see here that the first row doesn't produce any constant, but the second row does. Because if I want to go from 9 to 15, I have to add 6. 15 to 21, I have to add 6. 21 to 27, I have to add 6. So I know that this sequence here has got something to do with the squared numbers, because the second row, when the second row is constant, it's got something to do with n squared, for sure. And whatever number comes in the second row, you take that number and you divide it by 2. So that's going to be something to do with 3n squared. So it's definitely got something to do with 3n squared. So the way I like to continue from here is I like to write my this is the position. This is the position of the first term, position of the second term. Okay, so there's 5 terms. 1, 2, 3, 4, 5 represents the position. I'm going to find what n squared is. That's 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And then I'm going to multiply each of these by 3. So that'll be 3. 3 times 4 is 12. 3 times 9 is 27. 3 times 16 is 48. And 3 times 25 is 75. And then I'm going to leave a gap. And then I'm going to write down what my sequence is, the actual sequence that we want to find the sequence for. Let me just put these arrows here. That's going to be, there's 2 and 11 and 26 and 47 and 74. And we can see straight away there's some sort of link here. To get from 3 to 2, I've got to take away 1. From 12 to 11, take away 1. 27 to 26, take away 1. 48 to 47, take away 1. 75 to 74, take away 1. So that means this line is all just minus 1. So this is the sequence, 3n squared minus 1. Okay, 3n squared minus 1 will give us the numbers that we need. Okay, so how do I know it's got something to do with 3n squared? Because the second row produced a constant, which that when I take that constant and divide it by 2, it gives me the coefficient of the n squared. So I know it's got some relation with 3n squared. Okay, the fact that the second row gave us a constant, it's got something to do with n squared. And the coefficient of whatever the number that comes up constant there, you divide that by 2, that's the coefficient of n squared. And you can see straight away, we could see the link there. So it's 3n squared minus 1. And we can test, for example, let me choose a fourth term. 3 times 4 squared minus 1, that's 3 times 16, which is 48 minus 1, 47. So we know that it's working. So these are the answers to this question. Okay, now I mentioned that we'll have a look at this sequence here. And even though they didn't ask us to find the nth term, I'm going to do it just in case they give a question like this. So again, here we can see that the second row of differences this time, it's going to say minus 2, and minus 2, and minus 2, and minus 2, and minus 2. So it's one of those where you have the constant being in the second row. It's a constant. So we know it's got something to do with n squared, and we take the number minus 2 and divide it by 2. So that means it's got something to do with negative n squared. It's got some relation to negative n squared. So let's have a look at the first term. Let's have a look at the sequence. We have 1. So this is for n. n, 1, 2, 3, 4, 5. So n squared, okay. So this is negative n squared, not inside the bracket, outside the bracket. It's negative n and then squared, okay? So we can't think of it as being inside the bracket. So this will be minus 1, minus 4, minus 9, minus 16, and minus 25, okay? So that's negative n squared basically, right? I'm going to leave a gap, then I'm going to write down our numbers, which are 27 and 26 and 23 and 18 and 11. And we had some more 2 and minus 9, but we can leave it at that for now for the numbers that we have here. And we ask ourselves, how do I get from here to there? So from minus 1 to 27, I have to add 28. From minus 4 to 26, I have to add 30. Because I have to add 4. If I do, I have to add 4 to give me 0, and then I have to add another 26. I have to add 30. You can say that 30 minus 4 is 26. And from minus 9 to 23, so I can just carry on with the calculator now. Just what I have to add to minus 9 to give you 23? Well, that's the same as 23 minus 9, which is going to be 14. Minus 9, no, sorry, I want to come out. That's going to be 26 minus, yeah, so I have to do 23 minus 23 minus 9. Okay, that's going to give me 32, that's better. 32 minus 9 is 23. And 18 minus 16, that's going to give me 34. Okay, 34 minus 16 is 18. Just make sure that we're correct. So 18 minus 16 gives us 34. Okay, and 11 minus 25 gives us 36. 11, yeah, that's 36. So we can see that this sequence here, if I just look at this sequence by itself, this sequence is a sequence which goes up in 2s, right? I have to go up in 2 each time. So this sequence has got something to do with 2n. This is like 2 times n, because the first row of differences just for this sequence alone is going up by 2s. 28, 30, 32, 34, 36. So it's got something to do with 2n, okay? But it starts at 28. If I leave it as 2n, it's going to start at 2. So I have to add 26 to this to make it become 28. When n is 1, just this part alone, when n is 1, this is going to be 2 plus 26 is 28. This is going to be 4 plus 26, which is 30. So this is our sequence. Our sequence is minus n squared plus 2n plus 26. Okay, that is our sequence. Now, they didn't ask us to find that, but I'm just showing you the procedure of doing it. Okay, there's a procedure of doing it. That's just like a bit of an extension to this question. So we can check. For example, let's look at 1, 2, 3, 4, 5. Let's look at the fifth term. So this is going to be minus 5 squared. Now remember, this minus is not inside the bracket, so this is going to be minus 25. And you're going to have plus 10 and plus 26. So you have 26 minus 25, which is 1, plus 10, which is 11. And that's exactly the right term. So this is the correct sequence. As I reiterate, we weren't asked to find the nth term of the sequence. This was like a little additional part that I added to the question at the end, just in case maybe you might get a question like this that comes up in the future where you have a negative in front of the n squared. All right, you follow the same procedure as we did here. In this case, it was a lot easier because in this row, what came up here was just a constant number each time. So we had to just do minus 1. That's the constant number. There's no, it's just minus 1. So it's just 3n squared minus 1. But here we had minus n squared, but this itself was a sequence by itself, which is going up in 2s. So we have to think about this. This sequence is basically 2n plus 26 because it's going up in 2s, 2n. We want it to start from 28, so you have to add 26 because if you leave it as 2n, the first term would be 2. We want it to be 28, 2n plus 26. So minus n squared plus 2n plus 26 is that sequence. Okay, now, again, that's not required in this question. Okay, so in the end, I'm just going to get rid of all this. All right, that's actually not something that we required at all, okay, in this question, but it's just a bit of an extension to help you to, understand how to deal with such sequences if they come up ever, again. All right, something like that. So for this one, we had to understand that kind of principle. So that's basically the end of this question, which was a question mainly about these quadratic sequences, apart from the sequence A. So other questions from this particular paper will be found in the playlist over here when I get to answer them. I normally answer these questions by request. So if you look at the playlist, if you watch the video that's going to turn up here towards the end of the video, you'll see a link here for a video that you can watch. It tells you how to navigate through my channel. If you find that there's something missing that you want me to answer from a particular paper, send me a request, write a comment on the end of one of my videos, or and I will go and try to answer that as soon as I possibly can. So other questions from this paper can be found on the playlist, which will be linked at the end of the video over here. Other questions from this topic of sequences and number patterns, the playlist over here contains all the questions that I've answered from that topic for IGCSE. You can subscribe to my channel by clicking on this link. And as I said, the video here that will show will be a video which tells you how to navigate through my channel so you can find things in an efficient way. Thank you for watching and see you soon.